In the previous chapter, you learned about basic Python, including defining variables and loading modules. One of the modules that you loaded was called pandas. Pandas is a module for working with tabular data, or data that has rows and columns. Common examples of tabular data are spreadsheets or database tables. In this chapter, you'll learn the basics of pandas, including how to load and inspect data. Pandas gives you many tools for working with tabular data. You can load tabular data from multiple sources, like spreadsheets or databases, search for particular rows or columns in your loaded data, calculate aggregate statistics, like averages or standard deviations, and combine data from multiple sources. You already know two data types, floats and strings. Pandas introduces a new, more powerful data type, the data frame, which represents tabular data. Loading data into a data frame is the first step in using pandas. One of the easiest ways to create a data frame is by using a CSV file. CSV stands for comma-separated values and is a common way of storing tabular data as a text-only file. You can download a CSV version of data from an Excel spreadsheet, a SQL database, or a Google Sheet. Before we start using pandas, we have to import the pandas module. Recall that we always import pandas under the alias PD. Next, we create our first data frame from a CSV. Turning a CSV into a data frame is easy. We use a function, pd.readCSV. This function takes one argument, the name of a CSV file, as a string. In this example, the name of the file is ransom.csv. Notice that we saved this data frame to a variable called df. We can display this variable by using the print function, which we learned about in a previous lesson. When we print a data frame, we get to see every row in the data frame. In this example, the data frame is so large that it doesn't entirely fit on the slide. Usually, we don't want to print an entire data frame to inspect it. We just want to view the first few lines. We can do this by using head. Head behaves differently than the functions we've learned about previously. Rather than coming at the beginning of a line of code, this function belongs to the data frame variable and comes at the end of the line after a period. We call this type of function a method. The head method just selects the first 5 rows of df. In order to display them, we need to put df.head inside of the print function. Printing the first few lines of a data frame using head is much easier to read than printing the entire data frame. Another way of learning about a data frame is using the info method. Like head, we type the variable name of the data frame, in this case df, followed by a period, and then followed by our method info. Again, in order to display the output, we put the whole statement inside of a print function. Let's take a closer look at the output of info. Notice that we can see the names of the columns, the number of rows, and data types for each column. This method is particularly useful for data frames with many columns that are difficult to display using head. Now that you know what a data frame is, how to load data with a CSV, and how to inspect a data frame, let's continue to solve the mystery of Bayes' kidnapping. Now that we've loaded data from a CSV into a data frame, we're going to want to access that data. The first way that we'll use that data is by selecting columns. This means we'll be getting all the values from a particular column in a data frame. In this lesson, we'll continue working with the credit card reports for our suspects in the kidnapping of Baze, the golden retriever, as well as a few other pieces of evidence from the case. Why do we want to select columns? We might use them in a calculation. For example, this code selects the column price and then calls the method sum on that column to get the total amount of money spent by our suspects. We might also want to use the data as the input to a function. You might recognize this code from when we learned about functions. It will create a plot of the frequencies of each letter in the ransom node. The data comes from a data frame called ransom, with columns letter and frequency. So how do we select columns? We know that we can view the column names for our data frame using either head or info. If we examine the credit records data frame, we see that there are 5 columns: suspect, location, date, item, and price. Each of these column names is a string. Recall that a string is just a way of representing text in Python. In this case, the strings are all single words, but strings can have spaces or special characters. That means that the columns in data frames can also have spaces or special characters. We can use these column name strings to select a column. We type the name of the data frame, followed by an open square bracket, followed by the column string, in quotation marks, and closed with a second square bracket. If we print the column, we see all values for that particular column. There's a second way we can select columns from a data frame. If the column's string only contains letters, numbers, and underscores, we can use dot notation. For dot notation, we simply type the name of the variable, followed by a dot, followed by the name of the column. In this case, we don't use quotation marks around the column name. Let's go over some common errors you might encounter when selecting columns. Remember that when your column name contains spaces or special characters, you need to use bracket and string notation, and not dot notation to select the column. If you use dot notation, Python gets confused and thinks you're referring to several different variables. Another common error is forgetting to put quotation marks around the column string when using brackets and string notation. If you forget the quotation marks, then Python thinks that the column name is actually a variable that hasn't been defined yet. Finally, remember that square brackets are not the same as parentheses. If you use parentheses, Python will think that you're using the data frame as a function and will give a type error. You've learned how to select columns from a data frame, and you're ready to deal with any errors you might encounter. Let's practice. Welcome back. Now that we know how to select columns of a data frame, let's learn how to select specific rows. We've collected credit card statements from all of our suspects into a data frame called credit records. If we can prove that some of the suspects made suspicious purchases, we can ask them for writing samples and match those samples to the ransom note found at the scene of the crime. In order to search for the suspicious purchases, we'll need to select rows from the data frame using logical statements. In Python, a logical statement checks for a relationship between two values, such as equal to or greater than, and returns true or false. For example, suppose we want to know if 12 times 8 is equal to 96. We can compare the variables question and solution using a double equal sign. This tests whether the two numbers are the same. In this case, Python returns true because 12 times 8 is equal to 96. That true that Python returns is a special data type called a Boolean. There are only two Booleans, true and false. Recall that you've already learned three other data types: floats, strings, and data frames. We'll be using Booleans to select rows where the value of a column matches a specific value. We can make many types of comparisons in Python, such as greater than or equal to, less than, and less than or equal to. In this example, we ask if the variable price is greater than 5. Python returns false because 2.25 is not greater than 5. We can also check if two variables are not equal to each other. We do this using exclamation point followed by an equal sign. In this example, we see that lowercase a's is not the same as title case a's. In the previous examples, we were just comparing two values. In a data frame, we can compare one value to all values in a data frame. For example, we can compare if each purchase in our credit card records had a price that was greater than $20. This returns an entire column of true or false. If we put that truth testing statement inside of brackets, we can select only the rows where the statement is true. Here, we select rows of credit records where price is greater than $20. Let's examine this line of code more closely. We start with the name of the data frame we want to select rows from. In this case, credit records. Next, we have a set of square brackets. Inside the square brackets, we put our logical test. In this case, the logical test is whether price column of credit records is greater than $20. The statement will select all rows of credit records where the column price is greater than $20. Let's try another example. Suppose we want to select all rows of credit records where the suspect is equal to Ronald Aylmer Fisher. Again, we have the name of the data frame, followed by square brackets, and inside of the brackets, we check if creditrecords.suspect is equal to Ronald Aylmer Fisher. Note that we use the double equal sign to test equality. Great job, let's practice.